Okay, so the biggest difference here, we're still going to focus on U substitution, but the biggest difference is going to be, let's change colors, these limits of integration. And so when you see these, that means we're doing definite integration. And that means we need to apply that part of the fundamental theorem of calculus where we actually plug these numbers in. So we're not going to have a plus C in these questions. That's how you know, is if those numbers are there. And we're going to apply the first fundamental theorem of calculus to simplify it and clean it up. So this answer is not going to be an expression. It could be a part of your answer depending on how the question is asked, I suppose. But the final answer is actually going to be a value, whether it's an integer or a rational number, but it'll be a number. So I'm going to say, let's let U be equal to our x plus 3, right? So that tells us du is 1, because that's the derivative, right, times dx. So as far as a process, this is exactly the same as what we were doing. I'm going to keep my 0 and my 2, and I'm going to rewrite this as 1 over u cubed du. And you could write the du in the numerator if you want. It's just a option, it's a choice. And then I'm actually going to go one more step further from 0 to 2, and I'm going to write this as u to the negative third power du. So now when I integrate, I follow my normal power rule, right? The general power rule. I get u, if I add 1, that becomes u to the negative 2, and I divide by that negative 2. And then again, my kind of notation, I usually do a straight line or maybe has a little bar like this. And I have u is equal to 0. Actually, and the problem here, which we'll learn another way to correct this problem on the next couple of questions, but what we do is I actually need to return back to x because that's what these two numbers are kind of being measured with. So I need to go back to, this will be negative, and actually I'm going to write it in the denominator, 1 over 2 x plus 3 squared, and I'm going from x is 0 to 2. So that's a really important thing to focus on, is this discrepancy between the u and between the x. You really do need to pay attention to that. That's probably where I see, one of the places where I see the most mistakes in this is just kind of rushing the question. And like I said, there's other approaches to this called changing our variables. We'll see that in just a little bit. So to clean this up, I'm going to plug in first 2 and then 0, right? And I'm going to subtract, right? This is f of b minus f of a. So this is equal to, I have negative 1 over 2 times, this will be 2 plus 3 squared minus negative 1 over 2, 1 plus 3, 0 plus 3 squared. Again, I don't see any need to kind of rush to simplify this, especially if you don't have a lot of experience or practice with this kind of process. I see a lot of mistakes with just trying to get to the answer, right? And not being willing to write a couple more lines to get to the correct answer. So I have a negative, this is 1 over, I have 2 times 2 plus 3 will be 5, right? And so 5 squared, so 2 times 25. Negative means I'm adding, and I've got 1 over 2 times 0 plus 3 is just 3, so 3 squared, 9. Negative 1 over 50 plus 1 over 18. So I do not recommend turning these into decimals. Get used to fractions. We use them quite a bit over here. For some of you, you might prefer to write them vertically, right? Negative 1 over 50, positive 1 over 18. I do need a least common denominator. There is an approach to this. You may or may not be familiar with it. You may or may not like it. But if I take 50 and I write it as a product of its prime factors, so that's 2 times 5 times another 5, right? You think of 50, this would be 2 times 25, which is 5 times 5. 18 is 9 times 2 and 3 and 3. So 18 is, I already have kind of a space for 2, so I'm going to just copy it there. And then I need new spaces for my 3. So in other words, I just don't want to repeat. If I had a second 2, I would get its own column, okay? So the way that this works is actually the least common denominator is I just take one number per column, 2 times 5 times 5 times 3 times 3, or 50 times 9, which is 450. It's one way that I've found that works pretty consistently because all we're doing is factoring and eliminating essentially whatever they have in common, or using it once. Eliminating is probably the wrong word. So this would be times something to get us to 450. And the other great thing about this is if I want to know what that product is, I just look at what's missing. So for example, in the top row with 50, I'm missing 3 times 3. So here I'm going to say times 9 over 9. 50 times 9 is 450. Negative 1 times 9 is negative 9. And then in the bottom group, or the second row, 18, I'm missing 5 times 5. So that's going to be times 25. So that's going to be 25. And 25 take away 9, again, you can write them in the reverse order if you prefer. But 25 take away 9 would be 16.